Hi guys, how are you today? Today we're going to talk about some indifference identities, but we have added this week two new ones, which are the tan of x plus y and the tan of x minus y. And as you guys notice, those identities have two different forms, form A and form B. So some of you might have wondered why there's two forms. And if you think about it for a minute, if we're gonna go through the practice problems now, but let's say you had the A form. Now with the A form, if you had an angle where the tan is undefined, it's gonna ruin the whole expression and you can't use it anymore. So that's why in this case you use the B. And same thing for the difference identity. So it all depends on the actual problem. So for example, if you guys, I have included an example in here. So let's say we had x plus pi over 2. So if we apply form A, you guys can see that tan of pi over 2 is undefined, so it's going to ruin the whole expression. You can't add an undefined to a tan of x. So this is why we choose in this case the form B of this identity. And form B does not give us any undefined, and we can use it and prove whatever they needed to prove. So tan of pi over 2 is undefined because it's sine over cosine, and the cosine of pi over 2 is 0. That's why 1 over 0 is undefined. So we can't use form A, but we can use form B instead. So let's go back to the practice problems, and I did put the key. I just want to make sure to go over the key just to clarify if there's any questions. So number 16, tan of pi over 5 minus pi over 3. I put next to each one, if you're wondering what is that, it's 31a. That means I have used form A of this identity. So for 31a, if you apply it, you're going to see that you end up with tan of negative 2 pi over 15. And I put the identities right here. So 31a means tan of x minus tan of y. So tan of pi over 5 minus tan of pi over 3 divided by 1 plus tan of x tan of y. So 1 plus tan of pi over 5 minus pi over 3. And this should lead to the tan of negative 2 pi over 15. You can see the form. It's kind of going backward. Just making sure you guys understand that part. It's a little bit blurry in here. Yeah. So for 16, you have this side of the identity, which is 31a. So you have the actual form, and you want to go back to the x minus y form. So that's why you put those together. So it's pi over 5 minus pi over 3, which is negative 2 pi over 15. If you just make a common denominator. So that's what we made, a common denominator. Number 20. I would say, let's call it like the developed form, the loose form of the identity. We could also say right and left just to be on the same page. So it's a cosine one. And if you guys see, the cosine one is the 27, which is, or 26. Now here's an addition or subtraction. So we see a subtraction. We look right here. Subtraction is identity 26. And I put I26, which makes it a sum of two angles, which are the 7y and the 3y, and cosine of 10y. Number 21, also we see the loose part, the developed version, the developed form of tan. And in this case, it's 30a, because you see a plus on top and a minus on the bottom. So it's 30a, which is the sum of the two angles. So 2y plus 3x. And it's a one step and done. 22, similarly, it's 3 alpha minus 2 beta. Again, alpha, beta, Greek letters, just like X and Y. We just use them to refer to angles. Let's take a look at other examples as well. Number 29, it's the loose form, the distributed form, if you want, of 30A. And I put next to the problem 30A. So it's a sum. And in this case, the question is a little bit different. It says prove the identity. So I need to get to, not sure why it's so blurry today, 1 plus tan theta and 1 minus tan theta. So what I do is I have to use the identity. It's tan of theta plus tan of pi over 4 over 1 minus tan theta, tan of pi over 4, and I did apply the 30A. But we all know tan of pi over 4 is 1, which makes it 1 plus tan of theta on top, and 1 multiplied by tan of theta, that is just tan of theta. I did notice in the homework that you guys submitted, many of you did that common mistake, which we have been talking about since the beginning of the year, with trig or without trig. I cannot go ahead and simplify the tans. And the reason why is because we have addition. We said whenever we have a fraction, we have addition or subtraction on numerator or denominator, we are not allowed to simplify across. I can't simplify the tans. I can't simplify the ones. I did see that a lot in so many of the submitted homework. Number 37, also it's a proof. We look at it, it's a sign of a difference. I look at my identity, sign of a difference is 29. I apply identity 29, and the sign of pi over 2 is 1. I can't do anything with cosine of u. I leave it. Cosine of pi over 2 is 0. So which makes the second term 0, and I'm left only with cosine of u, and that's what was needed to prove. 38, it's a tan of a difference, and again, the reason why we're gonna use 31b and not 31a, because 31a has a tan, and what did we say the tan when we have a pi over 2? The pi over 2, the tan of pi over 2 is undefined, so I can't use form A. I gotta use form B. And some of you might see those and say, oh, you simplified across. No, I did not. And we cannot do that. What I did is I canceled this term due to the 0 right here, because 0 multiplied by sine of u is just 0. That's how I got rid of this term. Again, 0 multiplied by cosine u is just nothing. That's how I got rid of those terms, not by crossing top and bottom, even if they are exactly the same. We cannot simplify across in a fraction if you have addition or subtraction. So which will leave us with cosine u over sine u, which is the cotan, and that's what we needed to prove. The last two, number 40, secant. So secant is 1 over cosine. So 1 over cosine, and we apply the cosine of a difference, which is pi over 2 minus u. Cosine of a difference is 27. So we are going to apply identity 27 to the denominator. And we're going to be left with sine u. Why? Again, because cosine of pi over 2 is 0. That helps me get rid of the first term, because 0 multiplied by anything is a 0. Sine of pi over 2 is 1. 1 multiplied by sine u is just sine u. So 1 over sine is cosecant, and that's what we needed to prove. And the last one. So 41, cosecant is 1 over sine. And I apply, I think like whoever did that on the board skipped the first step, but it's okay. It's 1 over sine of pi over 2 minus u in parentheses. And sine of a difference, you can see that it's identity 29. So we did put identity 29. You apply it to the denominator. One of the terms is going to get canceled nicely because it has a 0 in it, because cosine of pi over 2, when you substitute it, is a 0. You get rid of that term and you are left with cosine u on the bottom, 1 over cosine is secant of u. Okay? And I kind of put right here a summary of all the sum and difference identities. You can print it, write it. But again, those, I know now you are using them. You are looking at the identities and you are solving the problem. But that's fine as long as you guys get used to them. They look very familiar to you because you're going to need them in the next math classes. And I hope this helps.